Good morning. We're going to talk today about some of the vocabulary words pertaining to chemical reactions, the different kinds of reactions that you can have. And remember that in a chemical reaction, a new substance is being formed from the pre-existing atoms. The first one, and one of the easiest ones to recognize, is what we call synthesis. Synthesis is when you make something. And this is taking two atoms, individual atoms or small compounds, and putting them together to form a bigger one. So you can see that the form here, A plus B gives you AB. The arrow means a reaction heading in that direction. A and B can be anything, could be any two atoms, but they will form a larger compound. So if you ever see a reaction that has only one single product on the right-hand side, it's almost certainly a synthesis reaction because the only thing you could have done would be to make it from smaller components. So one example here on the bottom, carbon monoxide, CO, plus oxygen, O2, forms two molecules of carbon dioxide, CO2, a synthesis reaction. We have two reactants, but only one product. Here we see the synthesis of water. Two molecules of H2 and one molecule of O2 form two molecules of H2O. The number of molecules is not so important, just the fact that we had two reactants, hydrogen and oxygen, but only one product, water, tells us this is a synthesis reaction. Now, the exact opposite of a synthesis reaction is a decomposition reaction. In this one, we start with one reactant and end up with two or more products. In other words, a more complicated molecule is being broken down into simpler molecules or individual elements. An example of this is taking cinnabar, which is mercury and oxygen, and forms a reddish powder, heating it up, and the oxygen floats away and the mercury is left behind. So we've broken down mercury oxide into mercury and oxygen. The next two are a little harder to explain. The first one is single replacement, and this is sometimes called single displacement. Whichever word they use, it's the same thing. A single replacement reaction, we start with a compound, AB, two elements together, and a single element, C. And what happens is C kicks out one of the elements from the compound and takes its place. So we end up with a compound and an element. We started out with a compound and an element. We end up with a compound and an element, but they're different. The element that is now free used to be part of the compound. The compound we have now is a new compound, but only one is replaced. So if you see a compound and a single element, it's pretty certain that you have a single replacement reaction. An example of this would be zinc plus copper chloride forms zinc chloride and frees the copper. Now, why did it do this? It's because zinc is a more reactive element than the copper was. It has to be stronger to be able to kick the metal out. And you can see here that we have the metals organized in terms of most reactive to least reactive. No surprise, gold is one of the least reactive ones, and elements like lithium and sodium would be much more reactive. They would be able to kick out anything beneath them. So on this list, any metal can replace a metal that's beneath it. Gold could really replace nothing. Now, even more complicated is a double replacement reaction. In a double replacement reaction, we start with two compounds, and we end up with two compounds. It's just that they're not the same compound. Instead of just one element replacing one, it's almost like they're switching partners. So we have AB compound and CD compound, and the B and D elements switch, so that now we have two brand new compounds. This is the kind of reaction that can have some pretty spectacular results because you're creating two individual compounds. That's where you can see color changes and precipitants, where a solid will form out of the liquids and suddenly sink to the bottom. You might see gases form. These tend to be the more spectacular reactions. But the way to know that you're dealing with this is look at your reactants and look at your products. Did you start with 2 compounds and end up with 2 compounds, different compounds? Double replacement reaction. To understand the last one, first we have to know what a hydrocarbon is. And it's very simple. A hydrocarbon is a compound that contains, get ready for it, hydrogen and carbon. Hydrocarbon. There's a lot of these. A lot of the natural gas, methane, these are all hydrocarbons. Fossil fuels are hydrocarbons. And what makes them special is we can burn them and produce energy. And that brings us to our last reaction, combustion. A combustion reaction is one most people would tell you, well, it's a fire reaction. But what's happening here is a little more complicated. Most people know that if you take a candle and put a glass on top of it, the candle snuffs out because it's losing oxygen. Oxygen is required for the fire. A combustion reaction takes a hydrocarbon, which could be wax, gasoline, coal, oil, natural gas, wood, and adds oxygen to it. As a result, you get a release of light and heat, the fire, and you produce as your products water. Yes, fire makes water, and carbon dioxide. If it's a complete reaction, a complete clean reaction, you start with a hydrocarbon and oxygen. You end up with carbon dioxide and water. Since most combustion reactions are not totally clean, we often end up with other pollutants that are, not as good for the environment, but that's a complete reaction. So how do you know you have a combustion reaction? Look at the reactants, look at the products. If the reactants have CH in any of its forms and oxygen as a reactant, and the result is carbon dioxide and water, it's a combustion reaction. You don't have to be told that there's a fire or smoke or light or anything. Any hydrocarbon plus oxygen has to be one of the reactants, and it produces water and carbon dioxide, combustion reaction. So to review, looking at the reactants and looking at the products tells you what kind of reaction you're looking at. Did you start out with 2 or more compounds, but only ended up with 1 compound? Synthesis. Did you start out with 1 compound and end up with more? Decomposition. Did you begin with a compound and 1 element? As long as you end up with 1 compound and 1 element, single replacement. Now, if you start out with a compound and an element and they just fused together and made 1 big product, well, that'd be synthesis. But if the individual element switches and leaves another element taking its place, single replacement. And if you start with 2 compounds and end up with 2 compounds, but they're different compounds, double replacement. And last, if you start with a hydrocarbon and oxygen and you end up with water and carbon dioxide, combustion. Thank you.